Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, let us see about terahertz sensors. So the flow of this PPT is first we'll see what is terahertz sensors, then the working principle, different types of sensors, its applications, advantages and disadvantages. So terahertz radiation, it's also known as T rays, occupies the electromagnetic spectrum between microwaves and infrared light, typically in the frequency range of zero point 0.1 to 10 terahertz. This region has long been underexplored due to the lack of efficient sources and detectors. However, recent advancements in terahertz technology have opened up a wide range of applications, including security screening, medical imaging, non-destructive testing, and environmental monitoring. So next we'll see about the principle of working of the terahertz sensors. So the sensing relies on the interaction of the terahertz radiation with matter. So many materials exhibit unique spectral fingerprints in the terahertz range due to vibrational and rotational modes of molecules. By analyzing the absorption, reflection, or transmission of terahertz waves through a sample, it is possible to identify its composition and properties. Key principles underlying here are: first one is spectroscopy, where measuring the frequency dependent absorption or reflection of the terahertz radiation to identify the materials based on their unique spectral signatures. Next one is imaging, where it creates images based on the spatial variation of terahertz radiation transmitted or reflected from an object. And finally is the time domain spectroscopy. Here, measuring the amplitude and phase of the terahertz pulses transmitted through a sample to extract its complex refractive index and absorption coefficient. Next, we'll see about different types of terahertz sensors. First one is thermal detectors, where it measures the temperature change induced by the absorption of the radiation. These detectors are broadband and do not require cryogenic cooling, making them relatively simple and cost effective. Some of the examples include bolometers and pyroelectric detectors. Bolometers measure the change in resistance of a material due to heating by terahertz radiation, and pyroelectric detectors generate an electrical charge when their temperature changes due to terahertz absorption. Next one is semiconductor detectors, where it utilizes the interaction of terahertz photons with electrons in a semiconductor material. So these detectors can offer high sensitivity and fast response time. Some examples are Schottky diodes and high electron mobility transistors, photoconductive antennas. Next one is superconducting detectors. So it offers the highest sensitivity of terahertz detection, but they require cryogenic cooling. Some examples include superconducting hot electron bolometers, where it measures the change in resistance of a superconducting material due to heating by terahertz radiation, and kinetic inductance detectors, where it measures the change in the kinetic inductance of a superconducting resonator due to absorption of terahertz photons. The next type is Gole cells, where it is a pneumatic detector that measure the pressure change in a gas-filled chamber due to the absorption of terahertz radiation. They are broadband and relatively sensitive, but can be slow. And finally, it is microbolometers, which are thermal detectors fabricated using microfabrication techniques. They consist of a thin absorbing layer suspended above a substrate with a temperature sensitive resistor used to measure the temperature change. Microbolometers offer a good balance of sensitivity, speed, and cost. Next, we'll see about applications of terahertz sensors. So they are used in various fields, like say in security screening by detecting the concealed weapons and explosives in airports and other public places. Next one in medical imaging, like in imaging the skin cancer, dental caries, and other medical conditions without ionizing radiation. It is also used in non-destructive testing by inspecting the materials for defects and hidden structures in manufacturing and in construction. It is also used in paramedical analysis in identifying and quantifying paramedical compounds and polymers. And in environmental monitoring, it is used for detecting the pollutants and monitoring the air quality. It is also used in agriculture for assessing the quality and moisture content of the crops. In telecommunication, it is used to enable high speed communication, which is a wireless communication. And in scientific research, it is used for studying the properties of the materials and biological systems. Next, we'll see about the advantages of terahertz sensors. So, the terahertz radiation is non-ionizing, making it safe for biological tissues, and it is strongly absorbed by water, making it useful for detecting moisture content and imaging biological samples. So, it's very sensitive to water. And next one is material specificity, where many materials exhibit unique spectral fingerprints in the terahertz range, allowing for selective detection and identification. And finally, uh, it can penetrate many non-conducting materials such as plastics, fabrics, and paper, enabling non-destructive testing and concealed object detection. And next one is disadvantages of terahertz sensors. So it has some disadvantages in spite of several advantages. So it is strongly absorbed by water vapor in the atmosphere, limiting the range of the terahertz systems, especially in humid environments. The relatively long wavelength of terahertz radiation limits the spatial resolution of the terahertz imaging systems, and also the development of the efficient and cost effective terahertz sources and detectors remains a great challenge. And finally, the cost can be expensive due to complexity of the technology and the need for specialized components. Hope you understood the terahertz sensors and its working. Let us take up some assessment questions. What is the typical frequency range for the terahertz radiation? So the answer is 0.1 to 10 terahertz. Next one is a common technique used for terahertz material characterization that measures both the amplitude and the phase of the electric field is called terahertz time domain spectroscopy. Thank you for watching this video.